Guys, am I audible? Please let me know in the chat box. Am I audible, guys? Okay, fine. Okay, guys, let's start the session. Okay, guys, who have been shared resume to me, I have already referred them. So mostly they will get called by Monday or Tuesday, and your exam will be on Thursday, guys. Prepare well. Okay, guys, before only I try to complete the most of the important things, then you can easily clear the level 2 as well. Okay, guys. Okay. The last session I was discussed about finding the peak element. Guys, what is mean by peak element? Let's suppose they have given one array supposed to be like this, right? So slowly it is increasing order, increasing, then decreasing, then decreasing. Right, guys? Let's suppose there is in one array 4, 5, 6, 7. It's slowly increasing, right? Now it's supposed to be decreased. Let's suppose 3, 2, 1. It's decreasing, right, guys? Last time I have given an array, that's a wrong one. So that's why, yes. See, guys, here you can clearly see from this is the 0 index, first, 2, 3, fourth index, fifth index, and 16 index. So here when it comes to 3, it's got peak, highest value. After that, what will happen? What has happened? Slowly it's decreased, right? So this is called a where we can find the peak. This is the peak value, right? How can we say, tell this is the peak? A left value is lesser than the current value. Let's take current value, and current value is greater than the right value. Let's suppose this is the ith index. It's supposed to be I minus 1. This is the ith index, right? This is the I plus 1. Guys, understand this one? So what we have to find? We have to find the peak element. Let's try to solve this one by using the linear search. Guys, what does it mean by linear search, guys? Linear search means you have to traverse the array from starting index to ending in end index, right? What is the time complexity in the linear search? It is O of n, because we have to traverse every element in array. Let's suppose here input array length is n. So that's why linear search is always take the O of n. Okay, let's solve this by using the linear search. Where we have to start? First index int I equal to 0. Sorry. I less than of array dot line I plus plus. Guys, here I have to find two things. First one is I minus 1 and I plus 1. So if I take here 0th index, Can we find 0 minus 1? What will happen? Minus 1. Array index will start with 0. So that's why I am starting with year 1. Guys, understand this one? Now try to find out the pk of the element. Okay. How we are going to be find? If array of I minus 1. What the condition, guys, here? The left supposed to be I minus 1 supposed to be the current less than the current element. So less than array of I. And what supposed to take here? And or are? It's supposed to be and, because it's supposed to be satisfy the both the criteria. So that's why we have to take and condition here. And what is the other condition? Array of I should be greater than array of I plus 1. Yes, I will tell you that thing. Right, guys? But what will happen, guys, here if I come to array length minus 1? Let's suppose this is the array. We have started 0, 1, 2, 3. We have started from here, right? I have taken I equal to 1. Let's see, when I comes to here, what will happen, guys? It is try for the I plus 1 element here. I plus 1. So I plus 1 will be 4. Actually, array size is 4. So maximum index is 3 only. But if you check for the fourth element, we will get the compile time error. So that's why here the limit array length minus 1. Guys, when we found the element, we are going to be print or return based on our requirement. Let's suppose I am going to be print here array of I. Or if didn't find, after that I am going to be print as a here. Once we found now, so no need to check other. That's why we break, right? After that, once come out of the loop, we are going to be write as a not found. Here you have to use the Boolean condition, whether we found or not. Based on that one, we have to do this one. I hope you know about that basic thing. Okay, guys, what is the time complexity for this one? The time complexity is O of n. Guys, this is the linear search. We are going to be search everything one by one, right? First, we are check for the 5, compare with the both previous element and next element, and next we come to 6, and again here check for the previous element and next element. When we come to 7, what will happen? Same previous element and next element we have checked. When it comes to year 3, same previous element and next. Here we got the found the index, so we comes out of the loop, right, guys? Let's suppose it is supposed to be here. Let's suppose here 8, 9, 1. What will happen? It will come up to here. So in the worst case, it is going to be run in a O of n time, right, guys? So that's why time complexity of this one is O of n. I hope you clear, guys. What is the space complexity for this one? Time complexity. This is the time complexity. What is the space complexity, guys? Guys, have you used any extra space? We have used extra space also here, I equal to 1. But these space are not increment with the size. If the input size increases, but the extra space sizes increases or not? No, it is not going to be increased. It is constant. So that's why space complexity will be O of 1. But the problem is here, when they have given one keyword as sorted. That means initially it is increasing, after it is decreasing. So let's check here. 4, 5, 6, 7, 8, 1, 3, 2, 1. Guys, right, guys? Here you can see from year to year, it is in a sorted order. Year to year also it is sorted. It is increasing order, but it is in a decreasing order. Whatever it is sorted only, right? So when you see the sorting order, what is the best possible way to optimize this one? We have to use binary search, right? In the binary search, we can implement time complexity will be O of log n, right, guys? Let's try to solve this question by using the binary search. Okay, guys. Guys, tell me what supposed to be condition should I take here? Guys, please let me know. Okay. Initially, what we have take? We have take start index. So start index always be 0. Initially always be 0. And what we have take? End index. What supposed to be end index? Array dot length minus 1. Right, guys? Now we have to use two pointers while start less than or equal to end. Right, guys? This is the base thing we have to take. Then we have to check for the condition. What the condition we have to check? First, initially we have to find the mid value here. Mid value here. What the mid value, guys? Start plus n by 2. Right, guys? Then we have to check initially the mid value is the peak element or not. How we are going to be check the mid value is the peak or not? If we already know the condition, what is that condition? The condition here, previous value, and if you found the mid value, that mid value previous value, and that means mid minus 1 supposed to be less than the mid value. And what about the mid plus value? Compared to the mid value is supposed to be greater than the mid plus 1. Right, guys? If suppose any index is supposed satisfy this condition, then we called as we found the peak element. Right, guys? Now we are going to be check. How we are going to be check? Mid minus 1. Guys, please try to understand mid minus 1. Supposed to be, guys, supposed to be less than array of mid. Right, guys? And what is the other condition, guys? Array of mid supposed to be greater than array of mid plus 1. Right, guys? So we found the element. That means no need to continue. So we can return the index, or we can return the value array of mid. Guys, here we can return whatever that's based on our requirement. If some questions they may ask like give the index. That time you supposed to return only index here and mid index. If suppose they may ask you the value, in that case you have to return array of mid. Guys, understand this one? Okay. What is the next condition, guys? If you found this is fine. If not, what is the next condition? Guys, please check this one. Here, what are the possible conditions we have? Guys, let's suppose this is the mid value. Let's suppose this is the mid value. What happened to the mid plus 1? Guys, this is the mid value. And in this case, mid plus 1 is a greater than. Right, guys? Mid value is lesser than the mid plus 1. Guys, understand? The mid value, this is, let's suppose this is 5 is the mid here. The 6 is the mid plus 1. But the mid value is, this value is lesser than the mid plus 1. That means only possibility we find the element right side of this one. Right, guys? We find the element, our peak element supposed to be right side only. Left side we no need to check. Right, guys? So that's why we have to check condition is if array of mid less than array of mid plus 1. Guys, in this case, what happened? Start will be mid plus 1. Guys, understand this one, how I have taken this one? Guys, check this condition. Let's suppose we found the mid here. Here, if suppose the mid here 2, what will happen? The mid plus 1 is 1. Guys, in this case, what will happen to this condition? It is going to be false. Right, guys? Let's suppose 3, 2, 1. We found the mid as this one. This is the mid. One is the mid plus one. This is the mid plus one. This is the mid. What happened, guys, in this case? Mid plus one, mid array of mid value is greater than, not less than, right? This is the greater than the mid plus one value. So it the false, it will come to the else case. Else case. What supposed to that value? If let's suppose, is there any way to that value supposed to be available in the right side? No, only possibility that value supposed to be lies between the left side. Right, guys? Guys, understand this one? Then what will be the end? End will be mid minus one. Guys, understand this one, guys? Please let me know. Guys, please let me know, guys. Have you understand this one? Yeah. Fine, guys. Let's suppose I have given one array here. Wait, guys. Okay, let's solve this question in Eclipse. Okay, guys? Guys, this array is not rotated array. Here I have given one array, right? This array is not rotated array, rotated sorted array. You have to understand this one. You have to because what will happen? Let's suppose 1, 2, 3, 4, 5, 6. If suppose I want to rotate two times left, what will be the value, guys? 3, 4, 5, 6, 1, 2. Here it is going to be increment, but still it's one step is decrement and again increase, right? So, but the input which I have given from starting to the peak value, it is going to be increasing. After the value, it is going to be decreasing. See, I have given what the value? 4, 5, 6, 7. After that, it is decreasing, right? 3, 2, 1. Guys, both are different. Rotated sorted array is different. Increasing and decreasing array is different. I hope you understand this one. Okay, guys. Okay, guys, we have created one class. Guys, what we have to do? We have to find that particular element. So I'm going to be create one method for that one. I'm going to be return that one. So that's why I have given as a int. Guys, understand how I am implementing? So I need only array here only. So that's why my parameter arguments is only array. If I need more, then only I will add. Now I'm not going to be use that one. Only I need array is enough. So that's why I have given as a int array. Okay, guys. Now what we have to do? We have to find the start index. What will be the start index initially? 0. Okay. Then what will be the end index, guys? Array dot length -1. Guys, understand why we have taken the array dot length? Because the array will be start 0 to length -1. That's why we have taken initially end value as this one. Then we have to use 2 pointers. So that's why I'm taking the while loop here. And here I'm taking start less than or equal to n. Right, guys? Let's solve this question. Initially, what we have to find? We have to find the mid. Int mid equal to start plus n by 2. Right, guys? Now, what we have to do? We have to check whether the mid index is the peak element or not. So, how we are going to check that one? Array of mid minus 1 less than array of mid, and what is the other condition, guys? Array of mid supposed to be greater than the array of mid plus 1. Right, guys? If we found the, what does it mean? That means we found the element. So that's why we are going to be written array of mid. Here I need only the element, not index. So that's why I have sent here written the array of mid. Okay, guys. What supposed to be next condition? If let's suppose if next element array of mid is less than array of mid plus 1. Guys, here we have taken one condition, right? Check. Array of mid is less than array of mid plus 1. What does it mean? Let's suppose we found the index as 5, here 5, the value is 5, next value 6. So that's why mid value is lesser than the 6. So that's why what supposed to indicate? It indicates our peak element supposed to be in the right side, not left side. So that's why we have taken start equal to mid plus 1. Right, guys? So that's why here start equal to mid plus 1. Right, guys? Then what is the other condition, guys? If not, this is not the true, what is the other condition? This one. Let's suppose here next mid plus 1 value is lesser than this one. So that's why value supposed to be right side of this one. Sorry, left side of this one. So that's why n equal to mid minus 1. I hope you understand this one. N equal to mid minus 1. Okay, guys? Okay. Let's give the array and we can test it here. Int array equal to, initially it's going to be increased. Let's suppose 4, 5, 6, 7, 8. And after that it will start decreasing. That means 3, 2, 1. Guys, what is the peak element here? 8. Right, guys? So let's see. We have to call this method, right? Find method, find of array. Once it returns this value, so we are going to print that value. That is we called as a peak, right? Let's check. It comes as a 8. Is that 8 only, right? You can check. Guys, I hope you understand this one. I hope you clear now. Okay, guys, fine. Next question will be, guys, now they have given array as rotated sorted array. Rotated sorted array. And ask you to find out peak element. Guys, understand this question, guys? Please let me know. Before, yes. Before we have given as a strictly increasing, then decreasing. But here rotated array. I have already told you that suppose this is the sorted array 1, 2, 3, 4, 5. Guys, 1, 2, 3, 4, 5. Let's suppose here, let's suppose 2 left rotation. That means 3, 4, 5, 6, 1, 2. Right, guys? Why 1, 2? First rotation, what will happen, guys? 2 will come here, 3 will come here, 4 will come here, 5 will come to before position. What will happen to first position? It will come to here. First rotation, it will be 2, 3, 4, 5, 6, right guys, and 1. What will happen after that? 3 will comes to this position, previous position, right guys, understand this one? So 2 goes to last, so that's why 3 comes first, 4 next, like that, 1, 2. Guys, understand this one? This is clearly rotated sorted array. Previous one, guys, this is very important. Most guys will confuse here, because here I have compared between the mid and mid plus one. Next we are going to be compare with different one. How we what we'll do, we can check here. Guys, what is the base condition to do this one? We have to always check. We have to take start value. Start value is 0. Next, int. What is the end value here, guys? Array dot length minus 1. Right, guys? Wait, guys. Okay, guys. What is the next step? While doing the 2 pointers approach, we have to take while loop. Right, guys? We have to take while loop. Then start supposed to be less than or equal to n. Right, guys? Then what is the next step, guys? We have to find the mid value. How we are going to be find the mid value? Start plus end by 2. Guys, now tell me one thing. Guys, now tell me one thing. This is the sorted, rotated sorted array. Guys, tell me, let's suppose this is the increasing, and after that decreases and increases, right? Here you can check. This is already sorted. The first value always be less than, greater than this last value, right, guys? Guys, before it is like this 1, 2, 3, 4, 5, 6, 8. It is already increasing orders, already sorted in increasing way. So 3 will be always less than 4, right? And what does it mean? If you take 5 also, compare 5 with the 3, it is always 3 value will be less only. If you take 6 also, the 3 value will be always less. Guys, understand? If you take 8 also, it will be always less. But here if you take 1, what will happen, guys? The 3 value is greater. But other values, if you take 4, 5, 6, 8, what will happen in this case? The end value, this is the end value here, it is always be less, end value is less. But if you take before values like 1 and 2, what will happen? This end value is greater. So what supposed to we compare here? We compare mid with end value. Right, guys? If we compare this one only, we will get the actual solution. What will happen? Let's suppose if it compare with the mid with mid plus 1. Let's suppose this is the mid one. This is the mid plus 1. Let's compare, guys. What will happen? Mid is always less here. Right, guys? If you take here also, let's suppose 2 is a mid. What will happen? Mid plus 1. Here also, mid value is less than mid plus 1. So that's why you won't get the conclusion here. So better thing, we want to take the condition between mid value and the last value. Guys, I hope you understand why I am comparing this one. Because I need some relation. That's why I am taking this one. Guys, what is the base condition? What are we take? Int start here. Start will be 0. Int end will be array length minus 1. Guys, check now what we have to do. We have while condition. Why while? Because it's a 2 pointer approach. That's why while we have to take start less than or equal to end. Right? In that case, what we have to find? First one, mid value. How we are going to find the mid value? Start plus end by 2. Right, guys? Guys, understand this one? Now check. Anyhow, we have to check this condition, guys. The peak value, that means the peak value always be follows the mid supposed to be lesser, and mid plus 1, sorry, mid minus 1 is lesser, mid plus 1 also. Like, wait guys, here you can check, this is the peak element, right? Here mid minus 1 also lesser, mid plus 1 also lesser. So we have to take first this condition, we have to check that condition as a first. Array of mid minus 1 less than array of mid. Right, guys? And what is the other condition here? Array of mid supposed to be greater than array of mid plus 1. Guys, understand? The peak always be same. Whatever in the sorted array, rotated sorted array are strictly increasing, decreasing. In the both cases, this condition will be same. Guys, understand? Please let me know. That's why I have taken. If you found the element, what we have to take? Return as array of mid. I need element, so that's why I'm returning this one. Then what supposed to be next case I have to check? I have already found the mid, right? If this case is not true, it will come here. So we are going to be check this one. How we are going to be check? We are going to be check with mid comparing with the last element. In this case, what will happen, guys? Mid always be greater than end. This is the start one, this is the end one. So these are all the values supposed to be are greater than this one end value, right? So that's why if I'm checking, I'm assuming like mid maybe in this part. I'm assuming like that. So that's why I'm taking as array of mid is greater than array of end. What does that mean, guys? Please let me know. If that means if this is the larger one, this is the smaller one, that means array is supposed to be between here this part only, right? Array is supposed to be this part only. So that's why start will be mid plus 1. Guys, understand this one? Please let me know, guys. Guys, please let me know. Guys, please let me know in the chat box. Because I'm not going to be repeat again because we have a less time. Okay, will do. Will do. Guys, rotated sorted array. This is the rotated sorted array. 4, 5, 6, 7. 1, 2, 3. This is rotated. This is the original array. This is the original array. 1, 2, 3, 4, 5, 6, 7. This is the original array. This is the rotated array. Guys, understand this one? Original array and rotated array. These are anyway sorted array. They give you like this rotated sorted array. Right, guys? Guys, please check me. Let's suppose this is increase. This is left rotated by one time. Left rotated by one time. What will be the final value? 2, 3, 4, 5, 6, 7, 1. Right, guys? Now check. Let's suppose this one value always be less than 2, always be less than 3, always be less than 4, and less than 5, less than 6, and less than 7. Right, guys? So that's why I am comparing with the mid value with the end value. Let's suppose here, let's take 1, 2, 3 here. This is the end value. This is the start value. Let's suppose I am considering mid as this one. This is the mid one. The mid one is greater or less, guys? Compared to 3, is 5 is greater. Right, guys? Compared to this one, this is also greater. I mean, compared to 6, compared to 3, 6 is greater. And compared to 3, 7 is also greater. Right, guys? If suppose I found mid value here, and comparing the end value, it is mid value. Let's suppose the mid value is higher than the end value. What does that mean? Here clearly see guys, this is the peak value. So the peak value will be the right side. Right side. So left side only, no need to check. No need to check. Guys, understand this one? Please let me know. Guys, please let me know, guys. Right. Super. So that's why I have taken here start as a mid plus one. Start as a mid plus one. What is the other condition here? Else. What is the else condition here? Let's suppose this is the array. Rotated sorted array. 1, 2, 3. Right, guys? Let's suppose this is the mid. This is the mid. We compare with the end. This is the end. Guys, what will happen here? Mid is lesser. Mid is lesser than the end value. This condition is going to be true. It is going to be false here, right, guys? Why false? Mid supposed to be here greater than the end value, but here mid value is lesser than the end value, right, guys? In this case, is there any possibility to get the peak value in the right side? Clearly, you can see the mid value, peak value is left of this mid value, right, guys? Left of, so that's why we take as the end to the mid minus 1. Guys, understand this one? So else mid equal to, else end equal to mid minus 1. Guys, understand this one? Please let me know. I'm expecting, guys, please let me know in the chat box, guys. The second else, how I have taken. Okay, fine. So let's solve this question in the Eclipse. Let's write it. Okay, guys. Peak in rotated sorted array. Okay. What is the condition, guys? What is the first thing we have to every time check, guys? I am taking a separate method. I'm not writing in the main method. I'm writing in the separate method. You have to also follow this one. This is the one of the Wood concept. I'm going to be written. So that's why I'm going to be written as a int. So that's why I've taken as a written and find method. What I need only array is enough. So that's why I have taken as an array as a parameter here. So okay, guys. Now what supposed to take? Int start. Start equal to 0. Initially always be 0. And int end will be array minus length minus 1. Right, guys? Please try to understand why initially array I'm going to be I have to check from the start 0 index to last index. So that's why I have taken as a here start as a 0 and end as a array length minus 1. Okay. Then 2 pointers. So that's why while loop. Understand, guys? Now start always be less than or equal to end. Okay, guys. What is the first step we have to take? We have to find the mid value. How we are going to be find? Start plus end by 2. Right, guys? Okay. Then what is the next step we have to do? We have to check whether maybe mid index, maybe the peak element. How we are going to be check that one? Compared with the previous, mid minus 1 and mid plus 1. Right, guys? In this case, mid minus 1 supposed to be less than array of mid. And what is the other condition? Array of mid value should be greater than array of mid plus 1. Right, guys? If it satisfies this condition, then we have to return the mid value, array of mid. Let's understand this one. What are the other conditions? If not satisfies this one, what the other condition? If array of, guys, here I am checking array of mid with the direct end value, not with the mid plus one anything. I hope you understand why I am checking this one. Let's suppose array of mid value is greater than array of end. Guys, here you can see this one. Mid with the, comparing with the array of n, and the mid value supposed to be greater than. In this case, what will happen? Start will be mid plus 1. Start equal to mid plus 1. Right, guys? Next, what is the other condition? If not, it's supposed to be in right side only. Sorry, it's left side. So that's why end will be mid minus 1. Here you understand, right? 1, 2, 3. Let's suppose mid will be 2. It value supposed to be left part only. That's why we have taken end equal to mid minus 1. Guys, understand, guys? Mid minus 1. Okay, guys. Next, call this method from the main method. We take one array here. 4, 5, 6, 7, and 1, 2, 3. This is rotated sorted array. The previous problem we have solved this one. This is increasing and decreasing order. Guys, see 4 to 5, 5 to 6, 6 to 7, 7 to 8. Then it is decreasing 3, 3 to 1, 1, 3 to 1 like that. But current problem, it is rotated sorted array. Previous array is 1, 2, 3, 4, 5, 6, 7. This is the initial sorted array. We have rotated this one in 3 times. 3 times left rotated. That's why 4, 5, 6, 7, 1, 2, 3. Guys, understand? Now I am calling the value. Int output equal to, okay, I can take as a peak equal to, find out what I have to give. I have to give array. Yes. This is the medium question. Guys, most of the guys will confuse here. Like what to compare, mid to mid plus 1 or mid to end. This is only tricky part. All other thing is same only. This is only tricky part here. Guys, here what you have to do. I am always telling you from non-decreasing order, like increasing order only. But you have to solve by your own questions, like decreasing order questions. Like that you have to solve. Then you will be very strong. Now we're going to print this one peak value. Let's check. Here peak value 7. We got it, guys. Super. Okay, guys, fine. Now the problems, assignment problems, guys. Guys, these are assignment problems. Please try to solve these questions, guys. Yes. Assignment questions. First one, these two questions you have to solve by like decreasing, then increasing. What I have solved the first question? First question I have did increasing and decreasing. I have given this is, I have explained about this one, but this question decreasing, then increasing. Okay, you have to find this element. I can call it as a depth element. Okay, guys, you have to find this element. This is your assignment question. Okay, guys. Second question, right rotated array. Right rotated array means, what does it mean by right rotated array? Let's suppose 1, 2, 3, 5, 4, 5, 6. Right rotated array means, let's suppose it's once means 6 will comes here. 1, 2, 3, 4, 5. This is the first right rotation. And second right rotation, what will happen? 5, 6, 1, 2, 3, 4. Okay, guys. You have to solve this question, right rotation array, and you have to find the peak element. Here the peak element is 6. You have to find it out how the solution will be. you have to try this by your own, then only you will be very strong. Okay, guys. It is a very like you have to find out which two things you have to compare. You have to find that element. Na, it's almost like 90% you solve this question. Okay, guys. Okay. Next question will be. Okay, guys. Guys, have you solved the questions like seal and flow question? I hope you solved those questions. Yes, yes. Yes, guys. After sentence, it sometimes they may give you, guys. This is a tricky one. Please try to understand this one, guys. If array size is, let's suppose array size is 5. That means let's suppose 1, 2, 3, 4, 5. Okay, guys. What will be happen here? I am taking the one left rotation. Left rotation, guys. This is very important thing. Please try to understand. First left rotation, what will happen? 2, 3, 4, 5, 1. Okay, guys. After again the one left rotation, what will happen in this case? 3, 4, 5, 1, 2. Okay, again left rotation, what will happen, guys? 4, 5, 1, 2, 3. And after fourth rotation, what will happen, guys? 5, 1, 2, 3, 4. After fifth rotation, what will happen? 1, 2, 3, 4. Guys, understand this one? Then if you do sixth rotation, what will happen, guys? Again 2, 3, 4, 5, 1. Guys, if somebody make in sometimes some tricky question, how they will ask? They will give you one array length n. Let's suppose array length is n. They may tell you array is rotated n plus 10 times. Left rotate 10. So how many times it's supposed to be rotated? Guys, understand this one. Sometimes they have given, let's suppose the array is 5. They may give you array length is 5. They may give you rotation is left rotation is 7 times. So what you have to do? How many times you supposed to rotate, guys? There is one simple formula for this one. They have given here 7, right? 7 percentile 5. This 5 means length. Array dot length. This is meant they asked you how many times. How many times? The percentile always give you reminder. In this case, reminder is 2. So only you have to do 2 times only rotation. 2 times only rotation. Let's suppose they have given 100 times. Okay, you have to rotate 100 times. But they have given the array length is 5. So how many times you have to rotate, guys? 100 percentile 5 means 0. So you no need to rotate. Guys, understand? It may give you 99 times you have to rotate. So you have to find it out. This is the number of times. This is the array of length. How many times, guys, you have to rotate? You have to rotate 4 times. Guys, understand? This is very important thing, guys. Very actually this basic thing you have to use like in previous next lessons you are going to be use these things. I hope you understand. This is very important. If any case, if they give you the array length of n, but they may ask you to do some operation more than n times. Okay, guys. So in this time you have to use n percentile. Okay. That how many times you may ask? Let's suppose here k times k percentile of n. So that operation you have to go perform remainder operations. I hope you understand this one. Here k percentile n, the remainder value. This is the very important thing, guys. You are going to be used. This one is a number of times. Okay, guys. Guys, next question. They have given you like they have given one number. Let's suppose they have given 64. They may ask you to find square root without any mathematical functions. Guys, what is the how many ways we can do it? Guys, please let me know. Okay, we'll do in a linear approach first. Linear approach first. How we are going to be do? I will start with the 1. I am going to be multiply with the same number. Same number. Okay, guys. I am going to be check this number is equal or not. Equal to 64. Equal? No. So that's why I am going to be increase. So I am going to be check like this. 2 into 2. Again I am going to be check. 3 into 3. I am going to be check. 4 into 4. 5 into 5. 6 into 6. 7 into 7. And last 8 into 8. So what will happen 8 into 8? When multiply with the 8 into 8, it will come to 64. So at that case, we are going to be stop this one. That rotation will be, we are going to be, iteration will be going to be stopped because we found the element. So 8 square root of 64 will be 8, right? So that's why we no need to go further. So we are going to be stop this one. Let's suppose they have given 169. 169. How many times I have to do? I have start with 1, continue with the 13. At the 13th place, we are going to be find 13 into 13, 169. Right, guys? What is the time complexity for this one? Guys, please let me know what is the time complexity for this one. We are continuing here every time one increasing 1 plus 1, right? So O of n times. O of n times. How O of n times? Let's suppose here I have taken for loop. Int I equal to 1. I less than and given number here. Let's suppose here number is 64. Okay, guys, I have taken as a number. Int number equal to 64. And I plus plus. Right, guys? So now I am going to be check every time I into I equal to number. Right, guys? If it is true now, if you find any element, we are going to be a return because no need to continue again. So until it is true, it is going to be find this element. Okay, guys. Just tell me one thing. If let's suppose they have given as a 15. Let's suppose they have given as a 15. N value 15. Guys, what is the square root of 15, guys? Square root of this square root may be between 3 to 4. 3 to 4. So in this case, we have to return something 3 point something it will come, right? We are going to be return the floor value. Guys, what is mean by floor here? 3.1, let's suppose 1 2 1 3. What is the floor of this one, guys? Floor will be 3. Guys, understand? Let's suppose you have to think like this, guys. It's 3. This is one scale. Let's suppose take the one scale. 3.5, 3.7. This is the 4. Okay, guys. Let's suppose this is the we are here. Let's suppose 3.5 we are here. What will be the seal here? Seal will be top. Here seal will be 4. This is the seal value. And what will be the floor for this one? This is the 3. Guys, you have to understand this one. This is the important thing. Seal will be 4 here and seal will be 4 and floor will be 3. This one floor. This is the seal. Guys, you understand this one? So if they may give you like 15, what you have to do? You have to find it out the floor value. So if you given the 15, you have to return as a 3. Guys, how we have to do that? In this case, okay, we are going to be check this case. It's not done, it's not true. Then else what we have to check? If I into I may be greater than num. Right, guys? Let's suppose we are here 3 into 3. It comes a our requirement is like 15. Number is 15 here. 3 into 3, it is 9. Right, guys? It's not true. It comes here. But here, what will happen? 3 into 3 greater than this number. Let's suppose number is here 15. So it's a false. Then what will happen? Again, we are going to be check here. I value will be 4. This case 4 into 4, it will be 16. So this is also not equal. But here 4 into 4 greater than number, right? Because this is a 16 greater than number. So what I will do? I am going to be written here minus minus I. Why? Because I need a floor value. But actually here I value now is 4, that is greater than, for example, I into I is a greater than of the number. So I need a floor value. So that's why I'm going to be written is minus minus I. Guys, understand? Please let me know this one. Guys, understand guys? Floor value. But the problem is here, time complexity is often. They may ask you to better way optimization for this one. So let's solve the optimization using the binary search 2 pointers. Let's suppose what is the here they have given a one number. Okay guys, number they have given, number equal to, let's suppose here number equal to, let's suppose 64. Right guys? So let's suppose this is the scale. Here it is 0. It is the 64. Guys, I am going to be find the mid element. What will be the mid element guys? Mid will be 32. 0 plus 64 by 2. What will happen? 32. Right guys? Now I am going to be check 32 into 32. It is 64 or greater than 64? It is the greater than 64. So that's why my value, like square root of this particular value, supposed to be this part only. Right guys? This is the start value, this is the end, 64 is the end value, this is the mid value. So it's supposed to be this part left side only. So that's why I am taking as here end will be mid minus 1. Guys, understand this one? Please let me know. Guys, please let me know guys. This is very simple one, simple question. Please let me know. Have you understand this one? Yes. Okay. Now what will happen? Start will be here 0. Now it comes to end value is, let's suppose here 31. This is the end value. What will be the mid value guys? Let's suppose mid value it comes as a 15. Right guys? Mid will be start plus n by 2. This will be 15. What will happen? 15 into 15. It is not equal, it is greater, even though the 15 into 15 also greater than our number is 64, right? So that's why it is also false. So we no need to check the right part. We have to check only end part, I mean left part only. Our value, our square root value will be lies the left part only. So that's why I'm taking end value is again mid minus 1. Right guys? Then what will happen? Let's suppose here, let's suppose we take the 16 here, the 32, 16. Now it comes to 8. This is the mid value. After, sorry, 16, right? This is the mid value 8. 8 into 8. 8 into 8 will be 64. We got our value. So no need to return. I am comes out of the loop. What is the time complexity of this one? Every time it is going to be 2 power, like 2 power k times, right guys? So time complexity will be log of n. Guys, understand? Guys, understand this one? Yes. Let's solve this one. Oh, we have to take initially here start value. Start value will be 0. And end value will be number. I want to check maybe from 0 to 64 given number. We have to apply for the 2 pointers. Right guys? Let's check this one. How we are going to be check? Start less than or equal to end. Right guys? Okay. What is the first case? First thing we have to do, we have to find the mid. Mid equal to start by end by 2. Then what we have to, base case, what we have to check here? If this mid value, mid into mid, equal to number. What does that mean, guys? If equal, so we found the square root mid. Guys, understand this one? Mid. Okay. What is the, if this is true, what is the other case? If maybe possibility mid into mid, so greater than of the number. Greater than of the number. What will happen, guys? So mid into mid means it will comes left side, right? So in the right side, no need to check. No need to check, because value of our square root value maybe lies between the left side only. So that's why we are taking here end equal to mid minus 1. What is the other case, guys? Else start equal to this one mid plus 1. Right, guys? Guys, I have already told you, like, wait, guys, I will take here one variable as a int result. I will take it as int result equal to 0. I am going to be here. Initially I told you, if suppose I have given one number 10, what will be the square root of 10? It's between like 3 to 4, but I am going to be take 3.14 something. I am going to be take floor value. Floor value will be the start value. So that's why I am going to take here one result variable I have taken equal to mid. Why? Because I have taken, guys? Because I just want to, let's suppose here it will return. If true, now it will return. If not the case, after end of this loop, I am going to be print. This result value. Guys, understand? I may suppose I want to return this one. That's why I have used here the floor concept. Floor, we are doing this thing only, right? We want to find the floor. We take equal to floor equal to mid. Guys, understand this one? Let's solve this question in Eclipse. Let's implement this one. Guys, if you didn't understand now, please let me know, guys. We have already solved this question. Okay, guys. We find let's solve this question. So we are going to be start with int start equal to 0. And what will be the end value? End value will be number. I have shown you in a graph, right? We are going to be checked from this, right? Wait. This one, right? 0 to 64. Right, guys? Now what we have to do? This is the 2 pointers approach. So we are start less than or equal to end. Right, guys? Now first thing what we have to do, we have to find the mid value. How we are going to be find the mid value? Guys, start plus end by 2. Right, guys? Right, guys? What is the next step we have to do? We have to check the condition whether mid into mid may be equal to the given number. Yeah, please check. It will come. You can check. Mid into mid equal to number. If suppose this is the number, what we have to do? We are going to be written mid. Okay, guys. What if not? If mid into mid may be greater than this number. So in this case, what will happen, guys? End will be mid minus 1. Else case, what will happen? Else case, start will be mid plus 1. Mid plus 1. Okay, guys. We are taking the floor, right? So that's why what I am taking here one result I am taking, result equal to 0. And here, if any case, I need a floor value. So that's why I am taking as a mid here. Okay, guys. After while loop, I will return result. Why result? If some case, for example, if I didn't find the mid value, what does that mean, guys? Maybe I need to return the floor. Sorry. If that is not a perfect case now, so we need to return the floor value. That's why I have taken here. Let's solve this question. I am taking as a number as a 16. What will be the square root of, what is the square root of 16, guys? 4. Let's check. It came as a floor. Let's suppose 25. 25 will be 5. What about 100, guys? 10. What about 400, guys? 20. Okay, let's check 10 now. 10 value supposed to be lies between 3 to 10 value 3 to 4. So we are taking the floor value. So that's why it's supposed to be 3. Let's check. It came, right? How it came? Here we are taking the mid value. It's not a mid plus 1. So let's suppose if I take as a 1 here. What it has written? 1. How it has written, guys? 1. Please let me know. Guys, how it has written the 1 here in this case? You debug yourself and try to understand that one. Okay, if I give 0, what's supposed to be its value? Its value is 0. Okay, guys. Guys, you have to do one thing. You have to, if there is a problem, you have to solve all the steps, debug everything from start to end. Then only you have to find the element, guys. You have to find the like logic. Why it's maybe something, it's not, maybe why it is a true, why it is a false. You may find if you solve the entire all the steps. Some guys what they do, if they do only first step, then what they will do, they directly give the yes. They may think that may not be true, so I did a mistake. You never think like that. You have to solve all the steps from first step to ending last step, then you will understand why this will be like that. Whatever it is, we can use it. That is okay, fine. We can use it. That. Guys, understand? That is okay. We can use it. Actually, this is the better approach. Like if now, if actually what will happen, whether there is no else case, it is going to be calculated one time, and again it is going to be calculated again. So better to, if you write else now, that's good only. Right, guys? Here we can do other things, like here there is some repeated operation is there, right? Here mid into mid. So I will take here I will take as a multiple equal to mid into mid. Why I am taking the mid into mid? Because I am repeating here 2 times, here also 1 time, here also 1 time. So that's why I am taking here. Guys, when there is a repeated operations is there, better to try to avoid that. Okay, guys? Fine. Or if you want to get the sealer, you have to do like this. This is only fine. That's it. Guys, okay, guys? 10 value will be 4. Because 10 value lies between 3 to 4. Guys, that's why I have already explained to that day. This is a very important thing. See, if you want to find the seal value will be the higher side. So that's why here, when it is the end value we are changing, that time we are taking here result equal to mid. But if you want to get the floor value now, floor value means like a lower side. Lower side means here lower value means here start. So when is start value we are changing, that time we are going to be change here. Guys, I hope you clear. I hope you understand this one, right? Please let me know, guys. Okay, fine. Okay. Guys, there are a lot more questions on binary search. It's not yet completed. I'm going to go solve other binary search related questions while I'm explaining about strings and 2D arrays. That means matrices. Okay, guys. It's not yet completed. Binary search is still there. There are a lot more questions is there. I'm going to be solved while explaining about the strings and 2D arrays. Okay, guys. As of now, how we have done, how we have calculated the binary search? We have calculated by using 2 pointers. The patterns mean what? Design patterns or number pattern, like how to print this one. These patterns you're talking about are design patterns. Number pattern. Okay, I will take after completion of this course, I will take 1 day because this is a 1 month course, right? After one completion, I will take that one. Actually, for any service-based companies like Infosys, TCS, that type of small companies, they may ask you about this type of number patterns. But if you go for the product-based companies, they won't ask you for this type of number patterns. But if you want to go, if you want to be good at iterations like loops or something, while loop, do while loop, if you work on these things now, like this design, print the these designs, you will be strong. You will be very confident about the loops. You will be get very good knowledge. Okay, guys. Guys, what does it mean by recursion, guys? Guys, I have to be a little bit fast because I have already told you the next week we have a opening slide. So that's why I'm taking a little bit faster. But I will complete all the questions, guys. No need to worry. Okay. Guys, as of now, what we have solved? That is, no one will ask actually pyramids or something, because that is a very basic thing. If you want to learn about, I think so in Johom, they may actually ask about print the Pascal triangle, something only they may ask. Okay. Guys, as of now, let's suppose this is the main method. We have one function here. Let's suppose here we have one function here. This is the one function here. Guys, here you have to understand this one. After the braces, if you give the semicolon, that means method calling, guys. Method calling. Guys, this is very important and try to understand. And after this parenthesis, if this brackets, if curly braces starts now, that means actual method. This is the actual method. Guys, this is the only method calling. This is the actual method implementation. Most of the guys confused here. If you're new to the programming. And one thing, there is a one function. Let's suppose here the main function is there. Main function, this is the implementation of the main function. So inside one function, let's suppose inside one function implementation, we can only call methods. We can't implement the methods inside the methods. Guys, understand? Here you can see there is a main method. In the main method, we are just calling this method, the function method. Guys, understand? Guys, I hope you understand this one. Please let me know. So what will happen, guys, when there is a function call? Actually, how the function call will be happen? This is the function call stack, guys. Stack. This is the function call stack. This is the function call stack. Okay, guys. So what will happen when we try to run a program, JVM, that machine, what will happen? It will call the main method first. So in the function call stack, what will happen? First main method will comes into the stack main method. Okay, guys. In the main method, what happened? We are calling the one function here. Calling the one function. So that function, let's suppose this is function one. That function one stack is going to be like that. Guys, you have to understand. So if you want to complete the main method, when main method will be completed? When main method will be completed? Wait, guys. When main method will be completed? Guys, let's suppose this is the stack, right? Stack, this is the stack. The before in the stack, what are the functions is there? If there is anything, all the things is completed. Once it is completed, that will be removed. So there is nothing is there. Let's suppose after the function one is completed, what will happen, guys? Function after the method, after the stack, what will happen? Only main will be there, because the function call has been completed, function is completed. Guys, understand this one? Then only main is going to be completed. If there is function is not completed, that means main is no way to complete first. Guys, understand? Let's suppose I will tell you one thing. First one, main method is there. Main method. From main method, I have called one function. I called as a function one. From function one to I have called as another function, function two. From function two to I have called as a function three. Function three to I have called as a function one. Let's suppose here I will show you the example here. Let's suppose the functions, right? Okay. This is the first main method. From main, I am first creating the methods here. Static void function one. Okay, guys, this is the function one. This is the function two. This is the function three. Like that, I have created some number of functions. Function three and function six and function seven. Okay, what I have did it first from the main method, I have called a one function. Function one I have called. Yes, please try to understand this one. Function one. So now call came from the initially it comes to main to function one. What I am doing in the function one, I am calling the function two. Function two, I am calling the function two. In the function two, I am calling the function three. Function three. In the function three, I am calling the function four. Guys, in C we called as a function. In Java we called as a method, guys. Sometimes I may use like a method. Sometimes I may use function. Don't need to confuse this one, guys. That's clear? Okay, guys. Guys, let's see in the stack what will happen, guys. Let's see here. Okay, guys. Let's see what will happen, guys. I'm going to be debug this one. I'm going to be debug this one. Guys, please on the line of 1 minute. Hello. Akka. చెప్తాను అక్కడ నేను బయట ఉన్నాను 10 నిమిషాలు మళ్ళీ కాల్ చేస్తాను గైస్ ఐఎమ్ ట్రైంగ్ టు డీబగ్ దిస్ వన్ ప్లీజ్ ట్రై టు అండర్స్టాండ్ దిస్ వన్ Guys, you can see this is the call stack. You can see third. This is the first thing what will happen. Main method is comes into stack. What will happen, guys? What will happen? The first main method is comes into the stack. This is the stack. First it comes to the main. Okay, what will happen next? Check, guys. It comes to the I didn't miss here. It comes to the function. Wait, guys. I missed this one. Check here. We have come to the function. Function one in main method. From main method, we are calling the function one. See what will happen? That function one comes in onto the this stack. See, initially main. Now what will happen? Top of that one, function one has come. What will happen, guys? Now it's a function one is came. Here, function one is came. Guys, please check this one. Try to understand. Now what will happen? Function 2 is came. But the remaining this main and function is still present in the stack. Okay, guys, function 2 has came. Next, what will happen? Function 3. Function 3. From the function 3, what will happen next? Function 4. From the function 4, what will happen? Function 5. From function 5 to what will happen? Function 6. Function 6 to function 7. Okay, guys. This is the function 7. It came. What will happen, guys? It came. End of this line, end of this function. Function 7 execution is completed. Now what will happen? Once this completion function execution completes means that function supposed to be removed from the stack. Now see, here the function 7 is there. Guys, function 7 is there. I'm going to be again run this one. I mean resume this one. Let's see what will happen. What will happen, guys? It will come to function 7 to function 6, function 6 to function 5, 4, 3, 2, 1. That's why entire thing is completed. Guys, understand this one? How this will happen? It calls to F2, then F3, then F4, like that. F5, let's suppose. What will happen from main to F1? It's called F1 to F2 called, F2 to F3 called, F3 to F4 called, F4 to F5 called. What will happen after the result came? What's the completion of the F5 function is completion? What will happen? It's going to be removed from here and result will comes to here. After what will happen? F4 is function completion completes. This is going to be removed and it will come to here. So what will happen after F3 function execution complete? It's going to be removed. It will comes to F2. After F2, what will happen? It comes to F1. F1 to main. Once main completion of the done, what will happen? Empty stack. See, guys, here. Have you seen this one here? Before there is a lot of things is there, main different functions is there, but here nothing is there after everything's completion. Guys, understand this one? This is the call stack. We can call it as a call stack. So normal function will be happening like this. Guys, understand this one? Guys, understand this one? So let's suppose when, guys, this is important. When the function will be removed from the stack, once the previous function, if let's suppose the previous function calls and that function execution completes. When the function execution completes, that means that is going to be removed from the stack. Guys, understand here? I hope you understand this one. Yes, you can say last in, first out. That means which function comes first? Which function? Here main function comes to first, right? That is going to be remove last. Okay, guys, this is very basic thing, guys, about functions. Okay. Then what does it mean by recursion? Please let me know. What does it mean by recursion? As of now, we have observed how function call will be happening. Now function. Let's suppose there is a one function is there. I want to like when I call a function, I want to do some repeated work, same type of work. I no need to create another method. Instead of the another method, I need to call a function, the same function. So you can see what does it mean? This is the function implementation. This is the function call. This is the function call. This is the implementation. This is the implementation, right? So what will happen? It is going to be call this function itself. Right guys, what will happen in this case? Let's suppose there is a main method. Let's suppose there is a main method. In that main method, I have called a one function. Okay guys. From that, there is a function. This is the one function. This is the implementation. I am calling here itself. What will happen guys? Initially, let's suppose first main will be comes here. After main, what will happen? It is calling the function. It will comes to the function. After comes to the function, what will happen? It is again calling the function. Right guys? It is again calling the function. So what will happen? In this function, that is the new function. We have to take it as a, that is a separate function. Okay guys? This function again it will call the another same function and same function. Right guys? It is calling like that. So what will happen if we have a didn't any condition here until how many times I need to call this function. If you didn't mention this one, what will happen guys? It will be comes a number of times like that. What will happen? Stack will be, guys, stack has some size, some initial size will be there. Size will be there. What will happen? Stack size increase, limit crosses. So we will get the compile time error. So what is the main important thing guys? When we work with the recursion, we should know how when I supposed to stop the recursion. When I should stop recursion. I should stop recursion. Guys, if you doesn't know, for example, if you want to work with a binary search, if you don't know when I have to stop this binary, recursion, better to don't go to the recursion. You can use it at 2 pointers to implement the binary search. Okay guys, this is very important. If you doesn't know the recursion, like base case, means when you supposed to stop the execution and the some recursion function call, you supposed to know. If you didn't know, you better to not implement that one. You can try to implement other possible way. Okay, but recursion is always easy way. I will tell you how to do that, how it will be easy. So first thing we have to, very important thing, first thing we have to know basic case. Basic case. This is very important. So we supposed to know the basic case. What does it mean by basic case? Basic case gives when supposed to stop the function call. Stop the function call. Stop the function call. Okay guys. Let's suppose I want to, they have given one number. Let's suppose they have given one number. Let's suppose 5. They ask you to find out addition of 5 to 1. 5 to, given number. Let's suppose this is the number n. That number to n. I am going to be implement that one. Let's suppose I have taken here the main method first. Okay guys, here int n number equal to, I will take it as let's suppose 5, and I am calling the one function here. Some function is there, I am calling here. Okay guys, some function here int n. Okay guys, Let's suppose I have taken, I know I need to repeat what I have to do. Let's suppose here the 5. What I have to do next? I have to remove, like decrement by 1, and I have to add like 5 plus. They have given 5 initially. So what I have to do? I have to 4. Then what I have to do? 4 plus, this is the 4. 4 plus 3, another call 3 minus 1. Then what I have to do? 3 plus, another call. Here what I have to do? 2 plus, another call. If you didn't know the condition where I have to stop, what will happen, guys? Next one will be 0. Next one will be minus 1. Next one will be minus 2. It's continuous. We will get the error. We supposed to know. Here they may ask you to count up to 1. So when n value 1, I have to stop. Let's suppose I have taken, if suppose n equal to 1, I supposed to stop. How we are going to be stopped? Here we are going to be stopped by using the return. What will mean by return? Return means it may comes out, it may return, it may goes from where it calls. Okay guys, let's suppose here I have given the return as a 1. So it is returning. Otherwise what we have to do? Return of that number into number plus sum of n minus 1. Guys, understand this one? What will happen in this case? Let's suppose here n value is 5. What will happen? It is going to be check here n equal to 1. No, it comes to here n value here 5 plus sum of n minus 1. What is mean by n minus 1, guys? What is mean by n minus 1 here? 4. So again another function call. So it treats the new function, this one. So what will happen? This one, same another function call. Here what will happen? N value will be 4. And again what you have? It is checking n equal to 1, true or false. It is a false, so it will come to here 4 plus sum of n minus 1. So sum of 3. Guys, you have to understand one thing here. I am not changing n equal to n minus 1. I am just calling the here n minus 1. So that's why this n value is not changed. I hope you understand. This is very important thing. So how the call will be there, right? Initially from the main n value is a 5. So what will happen here? 5 plus number of, sum of n minus 1, that means 4. Again another call. What will happen in this case? Here n value will be 4. 4 plus sum of 3. N minus 1 means 3. Right, guys? Then what will happen in this case? 3, n value here 3. 3 plus sum of n minus 3 means 2. What will happen in this case? Now another function call. What will happen, guys, here? N value will be 2. 2 plus sum of 1, n minus 1. What will happen in this case? Here 1 plus sum of 0. Right, guys? Okay. Here n value will be equal to 1, right? So what will happen? You can check, guys. Here we have taken as the n equal to 1. We have to return 1. So what will happen, guys, here? So n equal to return means where from it is called, it is going to be comes by that place. It will come, it comes to this function, but we are returning the here 1, n value 1. So where it is called, here it is called, it will give that value. N value is returning 1, right? So this value will be now 1. What will be 2 plus 3? This value will be 3. From where it calls, it comes to here. Right, guys? This value is 3. 3 plus 3, 6. This value where it calls here. So it will give the 6. 4 plus 6, what will be 10? So it will come to 10 value here. What does it mean? 10 plus 15, it is a 15. Guys, understand this one? Please let me know. Guys, this is very, very important thing, guys, and very confusing. When you're learning this recursion, everybody used to confuse here. Get the confused here only, but try to understand. It will be easy only. Guys, you have to understand one thing. When the function call is happening, what will happen, guys? When the new function call, for example, we are calling the here sum to sum only. but the new function will be called, that treats as a new one. Here also new one, here also new one, here also new one, here also new one, right guys? So every function call is treats as a new one. I hope you understand this one. Please let me know, guys. Have you understand this one? Yes, we'll tell you. Space complexity and time complexity will tell you. Okay, guys. Guys, please tell me. Here I have taken as a n value, input n value is a 5. How many times it has called? It has called, this is the one time, this is the second time, this is the third time, this is the fourth time, and this is the fifth time. That's it. So when there is here in this case, n value is 5, how many times it calls? 5 times. Let's suppose n value 10, how many times it calls? 10 times. Let's suppose the n value is 100, how many times it calls? 100 times. Guys, you have to understand time complexity means how many times it runs, right guys? Let's suppose here 100 times it runs. The 1 million means 1 million is n value is 1 million, that means it's 1 million times it runs. 1 billion means 1 billion. So time complexity here O of 1, O of n. Guys, understand? Guys, because every step it is going to be create another step only. Like first 5, next 4, next 3, next 2, here next 2, sorry guys, next 2 and next 1. That's it. So how many steps? Every step you can see. This is the one time, 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 this is the one time. So total 5 times. So we can, this is the 5, n value is 5. So that's why n of 5 times only it is going to be run. If it is a 1 million, it is going to be run in a 1 million times. So that's why time complexity is O of n. Guys, understand this one? Okay, guys. I hope you. Okay, guys. Now I am trying to create a one recursion function. How suppose it is supposed to be. Guys, I am creating the one recursion function, guys. Recursion function. Okay, guys. I have created a one recursion function. From this, I am calling a one function. Okay. Sorry, this is the normal main method. From main method onwards, I am calling the another function. Okay, guys. Check what I am doing here. I am creating the one function here. I just want to call this function itself. Guys, here I have written any base condition, like where I have to stop this function call. Have you, am I right? Written anything? Guys, did I written anything here? Where I have to stop? Please let me know in the chat box. Have I written any base condition here? Where it's supposed to written? No. No means like what will happen? It's supposed the stack is going to be overflow. So we have to get the compile time error. Let's see. Runtime error. How we are going getting the runtime error here? Let's see. I'm clicking on the button. Guess what will happen? We got a error here. Why we got a error? Because we don't know this function call when supposed to end. We don't know. It's always running, calling this function 1 to function 1. Number of times, infinity times it's going to be called. That's why we got a error here. Let's suppose what I have to do. I am taking here one static variable, static int count. Int count equal to, I have taken as a 0. I want to check every time I want to increase the count value. Here I am doing count value, I am trying to increase. And if my count value is equal to 10, equal to 10, I no need to continue. I just want to return. I know when 10 times is completed, I just want to stop, return this one. This is a base case here. Let's see how many times it is going to be run. Let's suppose I have taken as a 1. Let's suppose I have taken as like here. So you can see here how many times it's going to be run. Okay, guys. Let's suppose see how many times it has run. 10 times. 0, 1, 2, 3, 4, 5, 0 to 9 times, total 10 times. Guys, understand why it is runs only 10 times? Because we know the base condition where we want to stop this one. Where we want to stop this one. This is the very important thing in Recursion, if you don't know where to stop, then we will get the error. We must know where we have to stop this one. Guys, understand this one? That depends. Servanan, like the stack size also we can improve. We can increase. That is okay, fine. We can increase. That's not a fixed one. Everything like a stack memory, heap memory, everything we can increase. Guys, understand this concept? Please let me know in the chat box. No, it's not like that. I will tell you later. Guys, please let me know. Have you understand this one? This function call, why we need the base condition, where we have to return this one. This is very important. Guys, understand this one? Okay, guys. This is very, very important thing, guys. Okay. Let's try to implement our binary search. Our binary search using the recursion. Using the recursion. We are calling that binary one method from the main. We are calling the binary search method. Suppose binary search method is there. Let's suppose this is the search method there. Okay, guys. Guys, in the 2 pointers, what we need? What are the important things need to calculate the binary search? What are the things we are using? Yes, start we need, end we need, and mid. These are very important things, right? Start, end, mid. So every call I need to use this one. So that's why what I have to do, I am going to be implement a method as a binary search method. Let's suppose static. I want to return the index finally. So that's why I have taken as the int, and binary search method is the binary search. Guys, what are the important things we need? First thing we need array. Right, guys? So that's why we take it as a array, int array. Then what we need? Int start and int end. Okay, these are very important things. Right, guys? Now, yes, the mid we are going to be calculate inside, but the most important thing is what we need. We need array, we need start value, we need end value. Initially, these values we call from the main method. So what we are going to be, yes, that is also needed. Target also we needed. Int target also we needed. Target also we needed. Okay, guys? Yes. Okay. From the binaries, from the main method, what we have called? This what we have to find, we supposed to find start, where to start, where to end, what is the target value, what is the array. These things we have to call from the main method. Right, guys? We are called with this one. Array, start, int, start, end, and target. Guys, you have to understand one thing. While doing the two pointers approach, what we are changing every time? Are we changing the target every time? No, we are not changing the target. Are we changing our array? Given array we are changing? No. What we are changing every time? Maybe start, maybe end. These two only we are going to be changed. Right, guys? We are going to be changed these two only. Only these two. Right, guys? So that's why when the first step anyway, we have to find out the mid value. Here mid equal to start plus n by 2. Right, guys? So based on our condition, what is the condition? First thing we have to check for whether array of mid equal to number. So we are returning the here mid itself. We are returning the mid. That is okay, fine. What is the other condition? Else if array of mid is a greater than target. What does it mean, guys? Let's suppose here one array, let's say 1, 2, 3, 5, 7, 9, 10. Okay, guys, my target is 9. My target is 9. Okay, I'm taking as my target is like here 2. My target is 2. This one will be start value. This is the end value. This is the mid value. Right, guys? This is the mid value. Here you can check array of mid value is greater than target. My target is 2 only. Right, guys? So the value supposed to be the left side only, right? We have to check for left side only because that target value lies with left side only. So no need to check this one. So in this case, what we have changed? Have we changed the start value this point? No, we didn't change the start point here. We didn't change the start value. What we have changed here? Only the end value. End value will be mid minus 1. Mid minus 1. So when this case comes, like this condition is true, array of mid is greater than target, we are using the recursion. That means same method we have to call. How we have to call? How we have to call? We are calling binary search of. First thing, what is the first thing we have to send? Parameter here, array. The next one will be what? Start. What if we are changing here? End value. End value, what does it mean? Mid minus 1. The mid minus 1. And target value we are not changing. Guys, please let me know. Have you understand this one or not? Please let me know, guys. This is a very important thing. Have you understand this one? Yes. So, guys, while doing any recursion problem, better to avoid, like for example, here we are the things here there, start is there, end is there, target is there, and array is there. Better to not initialize this one, like you should not initialize this one. It is not recommended because we have a lot of problems while solving the questions. We should not, I mean, reinitialize. For example, here the end value is the mid minus 1, but we should not use here end equal to mid minus 1 and we cannot send the mid. I will tell you why I am telling this one. In future classes, you will know. Okay, guys? As of now, you have to understand one thing. You should not, which is the most important things we need to use. Those things we should not reinitialize. We directly call this one. Here, we are calling the end value like mid minus 1 will be end. Okay, guys? Understand? Understand, guys? What is the next case? Next else what will happen? Binary search array. In this case, what will happen? Start may be changed. Start may be what will happen? Mid plus 1. But end value will be same. And target. Guys, understand? Same what how we have solved in the two pointers? Same way only. Let's suppose here my target is 9. This is the mid one. Guys, you can check this value, this mid value, array of mid value compared to our target is smaller. So that's why greater than case is going to be fail. It will comes here. So guys, understand here in which part I have to check. My target is 9. 9 is right part or left part? Right part. Right part, our 9 is there. So n is not going to be changing here. Here we are changing only start value. What will be the start value? Mid plus 1. Guys, understand this one? So that's why in the start, while calling the start here, I'm giving as a mid plus 1. Guys, understand this one? Please let me know. Have you understand second condition how I have written? Okay. Okay. Guys, here one thing you have to understand. Here one thing you have to understand. Here we have another base case is there. We have didn't mention that one. Let's suppose every time we are taking start and end. Right, guys? We are finding the mid value, fine. In this case, in the while loop, like 2 pointers, what we are checking? S less than or equal to end. Right? But here, every time mid value is going to be, start value is going to be increment, end value is going to be decrement. Right, guys? Every time here mid minus 1 is mid plus 1, right? Start value is going to be increment. What will happen after some time? Start will be greater than end. Right, guys? If start will be greater than end, that time if we didn't find the element, that means we have to return -1. We have to return -1. Right, guys, understand this one? So that's why one or more basic case is here. If start is greater than end, we have to return -1. Guys, understand? Here also we are calling, right? So that's why we have to call it the return that particular function. Here also we have to call the return function. Guys, understand this one? Please let me know. Why I have taken one extra base case. Guys, base case is we cannot say only one base case. Maybe more than one also possible. Understand, guys? The base case may be more than one is possible. Okay, guys, let's try to implement that one in Eclipse. Okay. Binary search in recursive way. Okay, guys. Recursive way, we are going to be solve this one. Guys, I told you, right? Here I need to return index. So that's why I'm taking as a int here. And the binary search, I'm going to be write as the function name as the binary search. What I need here? Int array and int start, and what I other need? Int end, and what other thing? Int target I need. Right, guys? Because start index and end index, why we are going to be here? Because every time we need to perform the operations on start and end. Right, guys? That's why we are taking a start and end. Why we need target? We need to compare the mid value with the target. That's why. Why we here array? Because the index is from the array only. So that's why array we have taken. Okay, guys? First thing what we have to do, we have to find mid value. How we are going to be find the mid value? Start plus end by 2. Right, guys? Okay. Now let's write the base cases. What is the base case? If any time start is greater than end, means start is bigger than end. It's made possible because every time we are going to be start to the increment start, we are going to be increment the start by 1, and end we are going to be decrement by 1. So it's not always true like end will be more and start will be less. At some point in time, after several operations, end will be more than end, start will be more than end. So that's why this is the base case. What does it mean? That means we didn't find the index. That's why we are returning the -1 here. Whatever, guys, when we see the return, that means it goes back where it calls. Understand this one? Okay. What is the next base case, guys? If array of mid equal to target. What does it mean? We found the target at particular index. Return that index we are going to be give. Return mid. What is the other cases, guys? If, guys, try to understand, if array of mid is greater than, guys, please try to understand, greater than target. Guys, what does it mean, guys? Means array of mid value is already greater than target. That means the right side of the mid, no need to check, because when this is a sorted array, and the one value is like a mid value is already already mid value is higher than the target, then that right side of the mid value is also already higher values. So no need to check for the right side. We have to check only left side. So that's why we have to, what we have to do? We have to end value supposed to be, guys, end value supposed to be mid -1. Guys, understand this one? Mid -1. Guys, please let me know. Understand this one? What is the other case? Other case? Other case is maybe greater than. In this case, what will happen? Greater than means, sorry, less than means that value supposed to be, guys, please check this one. Guys, here 1, 2, 3, 4, 5, 6, 7, 8. Let's suppose my target value is 3. My target value is this is the mid value. So compared to the mid value, my target is smaller. Right, guys? My target is smaller. Let's suppose. So smaller means it value supposed to be this side only. Right, guys? The left side. So end value will be mid minus 1. Mid minus 1. Guys, understand this one? So let's suppose. So what will happen is the mid value. Wait, guys. Our mid value is greater than target. So what will happen? End will be mid minus 1. Just understand this one. Or otherwise, let's suppose my target value is like a 7. 7. This is the mid. Yes, compared to the mid value, my target is higher. My target is higher. Target is higher than the mid value. Right, guys? In this part, we have to check for the only right side. I hope you understand this one previously only. In this case, what will happen? Start will be mid plus 1. Because no need to check for the left side this time. Guys, understand this one? So that's why what will happen? Start will be mid plus 1. End will be, we are not going to be change anything. So that's why end. Guys, when we not change anything while calling the recursion, if anything no need, not going to be changed, that one we have to send as it is. Here you can see target, we didn't change anything, so target value same. So that's why we didn't change here. Here you can check array value, we didn't change because we are not changing the array value. So that's why we just sending as, calling that function with as it is. Guys, understand this one? I hope you clear this one. Okay, let's call this method. I have given one array, sorted array, int array equal to 1, 2, 3, 7 and 8. Okay, guys. Now target, as I have given as a target as like a 2. I need to find out here I am sending just the index, which index it has found. Okay, guys, I am going to put here we need to find first start value. What is the start value here? 0. What will be the end value here? End value will be array dot length -1. Right, guys? Okay, now we have to call the binary search here. From what we have to send array, and we have to send the start value, we have to send the end value, we have to send the target. These things will be parameters, right? This binary search, it is returning the one value, you can check every time returning, right? So we need to catch it. For example, int index, I called as index equal to this one. Guys, I am going to be print that one, that index, where I found that index. Okay, guys. Now my target is to, let's check. Where I got, it's got as a, it gives as a 0. 0 means 0 index. 0, this is the 0 index, this is the first index. I need 2, right? 2th index is first. Okay, guys. Let's suppose I have given is a 20. Guys, 20 is in the part of my list, my array? No. So it's supposed to return -1. Let's check. Did it return -1, guys? Guys, please let me know it is returns. So it is working. Guys, what is the change between, what is the difference between that previous 2 pointers approach and this recursive approach? Have you seen any difference? Here I am not, except the mid, I am not initializing anything. Right, guys? In the mid case, what I have done? Every time that 2 pointers approach, I am going to be initialized like start equal to mid plus 1, end equal to mid minus, like that I am going to be reinitialize in that 2 pointers. But in this case, in recursive approach, I am not going to be reinitialized. I am just sending the value. I hope you understand this one. Please let me know. Guys, have you clear this? Have you understand this one, guys? Yes. Okay. Now let's try to find out the time complexity here. Time complexity here. Time complexity. Okay, guys, they have given one array. This is the array. One, two, three, 4, 5, 6, 7. Okay, guys. What will happen in the first case? Start will be here, end will be here. Right, guys? Guys, you have to understand one thing. In this binary search, how many recursive calls is there inside? Actually, here 2 is there. But actually, whether every time only one call will be goes. Either it is true, na it will go. It false, na it will go. Understand this one? Not every time 2 calls. Only because of the if condition, either it will go or either it will go. Only this is the only possibility. Right, guys? So what will happening here? Let's suppose how it is going to be increment or decrement. Let's check. What will happen? The first case, what is going to be happen? Every time, let's take here, first time, start is not going to be changed. Let's suppose start is not going to be changed, but end is going to be changed to mid minus 1. Okay, guys? Let's suppose like this. Let's suppose what happened. Let's suppose here we got a mid. Now what happened? Start is going to be mid plus 1. Let's suppose we can say mid plus 1, but end is not going to be changed here. Yes, understand here end value is mid. Like that, what is happening, guys? Here every time initially its size is 8. After its size going to be 4. After the size is going to be 2. After the size array of the size is going to be 1. Guys, actually we are not changing the array. We are changing the here only indexes. Guys, initially here starting value 0, end value is 7. But after that, what will happen here? Start value will be, let's suppose start value will be 1, end value will be 4. What happened? We have taken this part. Let's suppose here the 2, here 4. Here let's suppose 3. Guys, understand? Every time what's happening? It is array is not array is not going to be like dividing. Just these indexes only going to be changed. Initially, the 8 index difference here you can check. These are the 8, but the difference is very less. 4 here less 2 here only 1. Guys, understand this one? So every time what's happening here? Array is going to be by number of by 2 power k times. Let's suppose here 2 power 0. Here what happened? 2 power 1. Guys, array is not changing, but the values I am changing. Difference between the small start index and this end index. What happened, guys? The difference here 8, here 4, here 2, here 1. So every time it is going to be decrementing. How much time it is? N by 2 power 1. Next time what will happen? N by 2 square. What will happen, guys? Here n by 2 cube. Here n is 8. N is 8, right? So it will be 1. So after 3 steps, that values goes to be 1. 1 means the indexes are same. Here start index or end index are both the same. Right, guys? So we need to divide up to when start index and end index is same. We have to count up to that one only. Right, guys? Please tell me one thing. What is mean by time complexity? What is mean by time complexity? Time complexity means how many times it runs. How many times it runs? Guys, understand how many times it runs? Yes. Here we have only 8, so it runs in it 3 times. Let's suppose we don't know. So what will happen? It will run up to n power k times 1 n by 2 power k times, right? This is the k means number of level. This is the number of level. This is the first level, 0th level. This is the one first level, second level, third level. Like that, 2 power k times it's going to be, I mean, k times it is going to be run, right guys? So how it will be in the last condition, what will happen? It is going to be 1, right guys? That means only one until one element is comes, until the subarray size, like here we are taking the subarray as end and start values, right? That value equal to 1, that start equal to end. That means these are same position, that means 1. That's why here n by 2 power k equal to 1. So n equal to 2 power k. How can we find the k? What is the k? K is number of levels, means number of times it runs, right guys? How we are going to be calculate this one? We have to apply the log both signs. This is also log, this is also log. So log n equal to k into log 2, right? Log 2 base 2, it will comes the value 1. So k equal to log n, right guys? So what is the time complexity, guys? Time complexity means how many times it runs. It runs in the k times. So time complexity is log of log n. Guys, understand this one? This is very important, guys. Help you clear this one. Okay, guys. This is the very basic thing. Okay. Let's solve the another example. Then try how many times it's going to be run. Let's suppose I want to find Fibonacci series. Let's suppose I want to find ninth number in the Fibonacci series. Guys, Fibonacci series, from where it starts? It starts with 0. It's next one. It is going to be add before 2 numbers. So 1. What will happen before 2 numbers? Before 2 numbers, guys. 1 plus 1, 2. What will happen before 2 numbers? It will be 3. Before 2 numbers. What will happen next before 2 numbers? 8. Next 13. Like that, right? It is going to be do like that. So if you want to find the ninth number, how many times? Every time we have to add previous 2 steps. I mean, this one and this one. So how we are calculate here? 8. Sorry, year 7, year 8. Right, guys? How we are going to be calculate the 7? How we are going to be calculate the 7? Either previous 2 things, right? 5 and 6. Right, guys? For 5, how we are going to be calculate? Previous 2. That means 3 and 5. Right, guys? 3, how many times? What is the way to, how can we calculate 3? Previous 2. What is the previous 2 of 3? Either 1, either 2. Right, guys? For 1, what is the previous case? Previous case is 0, n minus 1. Guys, if you don't know base condition here, what will happen, guys? If you don't know base case condition, what will happen? For 0 also we are going to be calculate minus 1 and minus 2. If you don't know base case condition, it will go like that. So that's why we know the base case condition. What is the base case condition? If either 0 or less than 0 or 1, we are going to be written that particular number. If for example 0, we are going to be written 0. If 1, we are going to be written 1. Right, understand? You mean less than or equal to 0. If any number is less than or equal to 0, we are going to be written 0. If any number equal to 1, that is going to be written 1. This is the base case. In this way, we can implement, right, guys? The same way, what will happen? Guys, please check here. Here, what will happen? 0, 1 is completed. Let's suppose 1, 2 is completed. 2, can we do that? How many times 2 can we do? Is 0, is 1. Right, guys? 5, how many times we can do? 2 times. What are the 2 times? 3 and 4. 3 how many times? Again 2 times. 1 and 2. Guys, understand this one. Same way it will happen like this. Guys, understand this one. 8 also we can, how many times you can do? We can do 7 and 6. Guys, understand this one. So what will happen? Initially this is the given number of, let's suppose this is the only one time. Second time what will happen? 2 times. Third level what will happen? 4 times. That means this is the 2 power 0, this is the 2 power 1, this is the 2 square, and so on. Let's suppose is the kth level, what will happen? 2 power k. Right guys? 2 power k times. Guys, understand? Let's suppose this is the 5th level, 32, that means 2 power 5, like that. Guys, understand this one? Please let me know. So total how many times it has run? It has done how many times? It has done in 2 power 0 plus 2 power 1 plus 2 square plus 2 cube and so on up to 2 power k times, right? What is the formula to add these all the time? These all actually time complexity means how many times it runs. How we'll get the how many times? If we add these all, we will get the how many times it has runs, how many times, right guys? Guys, we already know about geometry, I mean GP, right? If anything is in this formula, A into R for 0. Guys, wait. Shipshiva. Amen. Okay, okay. Guys, what will happen next? A into 2 power 1, A into 2 square, like that. If anything is in this way, what is the addition of all the things? There is a one formula. That what is that formula? A into R for n minus 1 by R minus 1. I hope you know this is the 10th class maths. What is the A value here? A value is 1. Everything is 1 into 1 into 1, right? A value 1. R value, what is the R value, guys? R value here 2, 2, 2, 2. R value is 2. What is here? N. N means number of times. So n minus 1 by R minus 1. Sorry, this is the 2, right? R minus 1, 2 minus 1. What will happen here? 2 power n minus 1 by 1. So 2 power n minus 1. Guys, understand this one? This is the time complexity of these many times it is going to be run. How many times? These many times it is going to be run. Right guys? So how can we calculate the time complexity? 2 power n minus 1. Right guys? What will happen? O of 2 power n minus O of 1. So we will take only higher terms only. So that's why time complexity for that one 2 power n. Let's understand this one. Please let me know. Guys, please let me know. Have you understand this one? In the chat box, please let me know, guys. Have you understand this? Okay, fine. Let's suppose, guys, this means, what will happen? This means, guys, there is every time it is going to be increase. I mean, 2 times it is dividing, right? That means in a recursive call, let's suppose recursive call, there are 2 recursive functions is there. That means 2 recursive functions. So that's why it's going to be dividing every times 2 times. If let's suppose there is 3 times. Guys, what will happen in this case? Yes, what will happen in this case? Every time it is going to be 3 times. Yes, right guys? Yes, here one thing we have to understand. If there is no, if let's suppose there is if case is there, it may gives you only one time. If else na, let's suppose only if else case, Maybe year one is there, but it will call only one time, because either this one or this one. Guys, what will be the time complexity of this one? How can we calculate? Guys, we are going to be calculated like this: 3 power 0 plus 3 power 1, 3 square and 3 cube, and so on up to 3 power n. Guys, how can we calculate? Same formula: a into r power n minus 1 by r minus 1. Here a value 1, r value 3. This is the n minus 1 by 3 minus 1. That means 3 power n minus 1 by 2. This is the time complexity. I hope you understand this one. Yeah. Guys, please let me know. Guys, this is very important things we are going to be used many number of times. Let's suppose there is some problems like generate valid parentheses. In this case, we have to use two recursive calls. If let's suppose in a dynamic programming, the most number of times we are using this, very commonly we are using this one, dynamic programming. And the like find a there is some cases like there is one function like the function. In this function, inside the loop there is a function call. I mean, inside the recursive also there is another function call is there. So it is called number of times. We are going to be find that permutation and find the permutation of the given number, like permutation of the given string. This is very important. I am going to be explain these things as well in future. Okay, guys. So that's why the basic. That's why I'm taking so much time on the recursion. This is very important. If you know recursion, you can solve any problem very easily. Like dynamic programming. This is very most of the problem in dynamic programming. Dynamic problems are mostly depend upon this recursion only, guys. I'm going to be explain I will take this as one template. So mostly I'm taking here a recursion only. In dynamic programming, I'm mostly use a recursion only. And like binary trees and graphs. The most of the times we are using these things only, like a linked list. We mostly use these things only, recursion only. So if you know recursion well, you can solve the questions like backtracing, the dynamic programming very easily. So try to understand. If you didn't understand, please try to watch YouTube videos or something. Try to understand every question on time complexity, everything, how they are going to be solved this one. Okay, I am going to be tell you now, like let's implement one simple question. Fibonacci, find Fibonacci. Find Fibonacci. Okay, not Fibonacci. We can do something else. I've already tell you, right? Okay, there is given a one question. In the question they mentioned as a I step, like he has given as a one step. I step is like n. Let's suppose here they have given a 5. So they say like you have to take only one or two steps at a time. Only one step or two steps, okay, at a time. So how many possible ways, guys? How many possible ways you can reach the fifth step? So what is the possible ways? Let's suppose I am here, nothing with 0. Now what I can do? I can take either one step or either one step or two steps. So now I reached to this the first step and second step. Now what are the other possibilities from here? What are the possibilities here? Again, I can take either one step or two steps. If I take one step now, I will come to second step. If I take two, I will reach to third step. Right, guys? Please try to understand this one. From the two, how many steps I can take? I can take another, again, one or two steps. If I one, I will come to third step. If I take two, I will come to fourth step. Right, guys? Now from here, how many steps I can take from two? From two, how many steps I can take? I can take one or two. If I take one, so total will be three steps. If I take two, will be four steps. Right, guys? From three, how many steps I can take? I can take either one step or two steps. If I take one step, that means it will be four steps. If I take two steps, that will be five steps. From three, how many steps I can do? I can do again one step or two steps. If I do two steps, that means five steps. Fifth step I can reach. If I take only one step, I will come to the fourth step. Guys, from the fourth one here, how many steps I can take? I can take only one step to reach the fifth one. I can't take, let's suppose I'm at the fourth one. If I take two steps, what will happen? Highest one is fifth only. I will reach this one. Right, guys? This is the, so there is no six steps, only five steps. So I have to take only one step here to reach the our of given step. So that's why I have to take only one. Here I can't take two steps. Understand, guys? Okay. Comes to here, how many steps I can take? I can take either one, either two. Right, guys? So if I take one step, how many steps I can take here? I will reach to fourth step. If I take two steps, I will reach to fifth step. Understand? Okay. From the fourth step, how many steps I can take? I can take only one. Only one. In this case, what will happen? I will reach to fifth step. Right, guys? Guys, can I take any steps from the fifth step? No, I can't take. What will happen? This one from 4, I can take only one step. So I will reach fifth step. Here also I can take only one. I will reach to 5. Here also I can take only one step. I can reach to fifth. Here also I can take only one step. I can reach to fifth step. Guys, understand? What is this concept called as? Guys, this is also recursion only. The concept we called as a back tracing. Called as a back tracing. Simply thumb rule, take as a thumb rule. Only one recursive call, the simple call. We call it as simple. The more than one, we can call it as a back tracing. And if we like do optimization on the back tracing, optimizing in the back tracing, we call it as a dynamic programming. Dynamic programming. Guys, see here where I can optimize. Guys, find it out here. Here I have calculated from the fourth step to fifth step here. One time I have calculated. But what I have done here? Here also I have calculated the same thing. Here also I have calculated the same thing. Here also I have calculated the same thing. So here also I have calculated the same thing. So what I have done here? I have done repeated work. Repeated work. Guys, you can see here from the third step I have taken, if I calculate this one, here also you can see again same thing I have done. Here also I have done same thing. So what I have done here? I have done repeated work. So if I save these values, if I store somewhere, so if I store the repeated work, store the work, if I need same work, I can call it from that I can call it from, I can say as a memory, right? Let's suppose I have done one work and I have saved that work in a one memory. I have stored the memory in the memory. So again, if I want to do that operation, like I want to do same operation, same work, I no need to work. I'm going to be check whether that work I have already completed or not. If I completed, that means I no need to again calculate that work. I just take that value from the memory. This is we called as a optimization from the backtracing. We called as a dynamic programming. This is we called as a dynamic programming. Let's suppose what is the time complexity here, guys? Initial 2 power 0, 2 power 1, 2 power square, like that number of times 2 power k. So time complexity here 2 power n. What will happen to that optimization way? What will do? I'm going to do store these values, guys. Store the values in some way. So what will happen? If 4 fights comes now, so I no need to calculate this one, no need to calculate this one. I'm going to directly take this value. When it comes to here, I no need to calculate, I will directly take this value. Here also I directly take this value. So in this case, what will be the time complexity here? One time, here two times, here two times, here also only calculate two times, here also only calculate two times, only calculate two times. So what will be happen time complexity? N2 into n. So time complexity will be only number of O of n. O of n means it's almost like a linear way. O of 1. So let's suppose there is a n equal to 100. Let's suppose n equal to 100. So 2 power 1 will be very used, right? So here O of n means only 100 times. So this many times of, instead of the running in this many times, we can just solve the same problem just in 100 times only. If we run the 100 times, we get the same solution. So this is we called as a optimization. Okay, guys. I hope you understand. I hope you clear on this. Okay, guys. So I'm not going to be solve this one now. Okay, guys. This is just introduction. I'm going to be solve in when I'm explaining about like tomorrow or day after tomorrow, I will explain about this. That time I will solve this question. Okay, guys. I hope you understand. I hope you clear on the recursion now. Please let me know if you guys have any doubt on the recursion, because recursion is a very important thing in the dynamic programming. In entire medium level and hard level questions can be solved by using the recursion only. Okay, please let me know, are you clear on this one? I'm going to be at the session soon, sir. That's why please let me know. Tomorrow I will take 2 sessions, guys. Tomorrow most possibly I will take session at a like 10 to 11 or 10 to 12 one session, and the evening another session. That will be same time, like 6 to 8 or 6 to 9. I will take these 2 sessions, but the morning session I am going to be complete the sorting techniques. Okay, sorting techniques. Okay, guys. Evening session I am going to be start with strings. Okay, I hope you clear. Guys, please try to solve as many as questions, guys. I have already give you some sample questions, guys. Try to solve as of now, like the 2 pointers. Try to solve this question. And I have already told number of questions on the binary search, right? Using the 2 pointers. 2 pointers binary search. Try to solve those questions by using the recursion approach. Recursion approach. So if you done this one, you will be very strong in the recursion, guys. So try to analyze the time complexity of, yeah, sliding wheels. I am going to be tell you, no need to worry. Sliding window, yeah, the sliding window and other techniques I will tell you. Most probably tomorrow, after the sorting techniques, I will do. I don't have a time, but I will try to do that one. Okay, guys, fine. Okay, guys, have you any doubts, guys? Please let me know. You guys any doubts? I will clarify now. Okay, fine. I'm ending the session, guys. Tomorrow it will be like 2 sessions, morning and evening. Please try to attend. Okay, guys, fine. Thank you.